Okay, so in this video we're looking at the function that's written here given on this interval, and ultimately the question that we're going to answer is what is the definite integral of the function on the given interval. But we're going to look at this definite integral two slightly different ways. So before I go into doing the calculus, let's just figure out kind of what this function looks like on the given interval. Of course it's quadratic, so we know its graph is going to be a parabola. And I'm going to take just a quick second to figure out where my zeros are. So if I solve this for x, real quick, take the square root of both sides, just doing some basic algebra. And let's see, if I solve this for x, you would get 1 plus or minus 2 all over 2. So you get negative 1/2 and 3/2. Just doing that real quick, so if I was going to do a quick sketch, I know that I've got a parabola that's coming through and hitting the x-axis at negative 1/2 and 3/2. Right, so we found that value and that value, so we can maybe get a little bit of an idea what this function looks like on the interval. Right, so I'm not making my sketch perfect here, but negative 2 is out here somewhere, and then 4, of course, out here somewhere. Right, so we can see that there's kind of, when we go and compute the definite integral, which gives us the area between the curve and the x-axis, right, we can see there's a piece right here, a piece of the definite integral, that is, a piece here and a piece here where we're above the x-axis, and a piece here where we're below the x-axis. So two different ways you could think about the area between the curve and the x-axis. I mean, you've got this region, and this region. If we compute the definite integral from negative 2 to 4, it will be built in that a1 and a3 are positive and a2 is negative. Right? So the number that we get is going to be a1 plus a2 a1 plus a3 subtract out a2. Right, now we could go find a1, a2, and a3 separately and add them all together, and that would give us the absolute area between the curve and the x-axis. Right, but if we go and we do this calculation, that's going to account for a1 and a3 being positive and a2 being negative because a2 falls below the x-axis. So the way I would do this computation is maybe with a quick u substitution. Let u be 2x minus 1. So du would be 2 dx, which means that dx then would be 1/2 du. Right, so of course this is going to equal what, my constant 1/2 I'm going to go ahead and pull out of the integral. This would be then just u squared minus 4 with respect to u, and I've got to change my limits. Right, so here when x is negative 2, u is negative 5. And when x is 4, u is 7. Okay, so from here it's just apply the fundamental theorem of calculus. So let's see, 1/2, and I'm going to take my antiderivative. And since my limits and everything are all in terms of u, I don't need to convert back to x or anything like that. And so from here, it's just a matter of being careful, right, when you do the calculation. If I plug 7 in for u, that's 343 over 3. 4 times 7 is 28. If I plug negative 5 in and cube it, that's negative 125. And negative 5 times a negative 4 would give me positive 20. Right, so I'd add all these numbers up and of course multiply by 1/2, and you should find that that comes out to be 54. Right, now if you wanted, somebody said, well, what's the absolute positive area, right? What's area 1, area 3, and area 2 combined if you consider them all positive, which we wouldn't do when we compute the definite integral, but we could approach the problem that way. Then we'd have to break this up into 3 separate integrals, right? So we could say, well, we want to know what the area is on negative 2 to, well, let's see, our first 0 was at negative 1/2. And we'd have to integrate the function with respect to x. And if we do that, I'm going to assume you can handle applying the fundamental theorem of calculus. You should get 13.5. Right, and then separately, we'd have to compute the integral from negative 1/2 to 3/2. So it's going to be maybe a little bit tedious with those fractional limits. Right, but if you do that, you should be able to go through, and actually we would find this is approximately equal to negative 5.33, 16/3, right? Negative 5.33, right? But if we were interested in the absolute area, we would treat that as just a positive number. Treat that as just a positive number, and then finally we do the integral from 3/2 out to 4. Of the function and again, if we approximate that, we should get 45.83. So if somebody said, well, what's just the absolute area, right? We would take this number plus this number plus this number, which I didn't do ahead of time, so let's see if I can add those up. So we get approximately, if we add those together, 64.66 as our absolute area. And of course, if you had wanted to keep these as fractions, you could have done that, which might have been better to get a more exact answer. But what we also notice is that if we take 13.5 minus 5.33 and then add 45.83, we come to our original answer, which is 54. Right? So if you want the definite integral from negative 2 to 4, you end up with 54. Thinking of the areas as just positive numbers, you end up with, of course, something a little bit different. So hopefully that helps give you a couple of different perspectives on the area between the curve and the x-axis.